Hello students, today we learn extranuclear part of electrons denoted by letter E. Electrons are negatively charged particles. It means electrons. The extranuclear subatomic particle is called as electron. These electrons, they carry negative charge. As they carry negative charge, they are negatively charged particles. Electrons are denoted by small letter E. Okay, see with negative symbol on their head. 1 unit negative charge is written like this minus 1e. The mass of electrons is 1800 or 1800 times less than that of hydrogen atom. That's why the mass of an electron can be treated as a negligible. The mass of electron is negligible. Why? Because its mass is 1800 times less than hydrogen atom. The extranuclear part in the atomic structure, it includes electrons revolving around the nucleus and the empty space in between the nucleus and the electron. It means outside the nucleus there is an empty space. Okay, and then the electrons, these are the third subatomic particles that revolves around the nucleus in their specific orbits. Electrons are present outside the nucleus. The part of the atom which is outside the nucleus, like orbits, different orbits, then space of the atom between orbits, between nucleus and orbits, and then electrons. All these together called as extranuclear part of the atom. These electrons, they revolve in this discrete orbit. What is meant by discrete orbits? The orbits, separate orbits. So electrons revolve in this orbit also, which is closest to the nucleus, then second from the nucleus. So electron revolves in this discrete. Discrete means what? Separate orbits around the nucleus. As these orbits are three-dimensional in nature. So the term shell is used instead of the orbit. The energy of an electron here. So the energy of electrons of first orbit or first shell is determined by the shell in which it is present. So this is first shell, this is second shell. Okay. Students, remember one thing. The number of electrons outside the nucleus are always equal to number of protons that are present inside the nucleus. Number of electrons carry negative charge. Means number of negative and protons carry positive charge. It means the number of negative charges is always equal to number of positive charges. As both the charges are equal in magnitude, these electrical charges are balanced, and that's why atom is electrically neutral. Why atom is electrically neutral? Because the number of negative charges equals to the number of positive charges inside the atom. Negative charges are present on the electrons which revolves around the nucleus. Number of positive charges are present on the protons which are present inside the nucleus. Both the charges are equal in magnitude. Atomic number. The number of protons in the nucleus of an atom is called atomic number. As we learned, number of protons is equal to number of electrons. Hence, there is another definition in terms of electrons. The number of electrons in the extranuclear part of an atom is also called atomic number. Atomic number is denoted by letter Z. For example, carbon. Its symbol is C. Carbon is having protons. Number of protons in the carbon is 6. Therefore, atomic number of carbon, that is Z, is equal to 6. We learned that number of protons is equal to number of electrons. Carbon has 6 protons, therefore number of electrons in carbon is 6. Use your brain power. How many types of subatomic particles are found in atom? 3 types of subatomic particles found in atom: the proton, the neutron, and electron. Which subatomic particles are present in the nucleus? The proton and neutrons are present in the nucleus. Which subatomic particle are electrically charged? Proton is positively charged subatom particle and the electron is negatively charged subatomic particles. Where are electrons revolving around the nucleus placed? Electrons revolve in the discrete orbits around the nucleus. Discrete, separate. Now we know that mass of the electron is 1800 times less than hydrogen atom. So the mass of electron is negligible. Therefore, the mass of atom is mainly due to the protons and neutrons in nucleus. In short, we can say that mass of the atom lies in the nucleus. Atomic mass. It is denoted by letter A. The total number of protons and neutrons in an atom is called atomic mass of an atom. Now, how to calculate atomic mass? We'll take an example of carbon and learn about it. Proton is denoted by letter P. Therefore, P is equal to 6. Neutron is equal to 6. Then atomic mass is equal to question mark. We know that atomic mass is total number of protons and neutrons. So the formula of atomic mass is atomic A is equal to P plus N. A stands for atomic mass, P stands for proton and N stands for neutron. Now atomic mass is equal to 6 plus 6. Then atomic mass is equal to 12 Dalton unit. Now this is the atomic mass of carbon. We'll consider or we'll learn and make it perfect with the help of another example. Sodium. Sodium have protons 11, neutrons 12. Then what is atomic mass? You find out. A is equal to P plus N. Okay. Though I calculated, but don't look at the screen and solve on your own. Students, observe we can see symbol superscript A and subscript Z. What is it? It is a convention to denote atomic symbol, atomic number and mass number together. We'll learn with the help of carbon. Now the symbol of carbon is C. Okay. Then this is atomic mass. Because it is superscript, means written upside. It is subscript, written downside. So symbol carbon, atomic mass 12 and atomic number 6. Then how to read oxygen? Symbol of oxygen is O. O 16 8. What 16 stands? 16 stands atomic mass and 8 stands atomic number. Again one time. See, the symbol of magnesium is Mg. Atomic number Z is equal to 12. Atomic mass A is equal to 24. Now conventional symbol Mg, symbol of atom. Superscript A, atomic mass. Subscript Z, atomic number. So Mg 2412. 24 stands for atomic mass and 12 stands for atomic number. Students, from this convention we can find out neutron also. See, from carbon we will find neutron. How to read convention? C 12 6. What is this 12? atomic mass and 6 is atomic number. So the atomic number, that is, what is atomic number? Atomic number means number of protons. So how many protons are present in carbon atom? 6 protons. And atomic mass of carbon atom is 12. Now how to find out neutrons? So with this information, atomic mass is equal to 12, protons is equal to 6, then neutron is equal to question mark. We know that neutron is equal to atomic mass minus proton. This is the formula to find out neutrons. From given, write down neutron is equal to 12 minus 6. So what is the number? So total number of neutrons is equal to 6. Second example, we'll take calcium. Atomic number of calcium is 20. That is, number of protons is equal to 20. You can write there number of electrons is also equals to 20. Yes. What is atomic number? Atomic number means number of protons or number of electrons. I gave it with two definitions, one with protons and one with electrons. Now Z is equal to 20. What is this Z? Atomic number. Atomic mass is equal to 40. Then neutrons is equal to question mark. Atomic mass, what is it? It is the sum total of protons and neutrons. So what is the formula of neutron? How to find out neutron? Neutrons is equal to atomic mass minus protons. Neutrons is equal to then 40 minus 20. So the total number of neutrons in calcium is equal to 20. Distribution of electrons in orbits. We know this is a nucleus. Around it, extranuclear part, space and first orbit. So these orbits are numbered as 1, 2, 3, 4. Okay. The first orbit is numbered as 1 and it is denoted by K. Now see, again this is nucleus in which proton and neutrons are present. Now these orbits, first one is denoted by letter K, then alphabetical order. After K, L comes. So second orbit is named as L. These orbits are called by another name shell because these are energy levels. And their numbers are, first one, K shells number is 1, then L shells number is 2. So the second shell is named as L. First shell is named as K. You will see here total number of shells of atom. This is at center nucleus is present. Then first shell K shell, second shell L shell, third shell M shell, and fourth shell's name is N. What this N stands? N stands as an ordinal number. What is meant by ordinal number? This number, it tells us positions like first, second and third. So N tells us that this first number of our shell is K. Here N tells us that second number shell is L, and 3 tells us that third number shell is M, and N is equal to 4 tells us that fourth number shell is N. As there are number of shells, then how many electrons get accommodated in that shells? So the maximum number of electrons in a shell is find out by the formula 2n square, where n stands for number of that shell, ordinal number. Now we'll learn with the help of these shells. First shell K, so its ordinal number is n. Now formula is 2n square. I forgot to write there. So what is that formula? With red color I wrote 2n square. Now put the value 2 multiplied by 1 square. 1 square means 2 into 1 into 1 is equal to 2. How many electrons get accommodated in that K shell? 2 electrons only. Now L. The L is second shell. So ordinal number is 2. Formula to find out electrons 2n square. Right then. Put the values in the formula 2n square. 2 into 2 square. That is 2 into 4. How 4 came? The square of 2 is 4. So 2 into 4 is equal to 8. How many electrons accommodate in L shell? 8. Now M shell. Its number is 3. Put the values in formula. So 2 into 3 square. That is 2 into 9. So M shell have capacity to accommodate 18 electrons. This is last one. N. Fourth shell. Ordinal number n is equal to 4. So 2 into 4 square. So 2 into 16. So the capacity of n shell is 32 electrons. Students, we are finishing this session of the lesson. We'll meet in next session. Till then, bye.